everyone.
Thank you for the introduction. So yeah, my name is Czarek. I work at Cake Wallet, and I'm the one who implemented embedded Tor in Cake Wallet. So before we start, let's get some vocabulary straight. Like, what is embedded Tor? Or actually, let's start first. What is a non-embedded Tor? Because we have to get there some way. So if you go to your favorite app store or web browser and look for Tor for Android, you will end up with something like Orbot or Invisible Pro, which is a very good software. Orbot is maintained by Guardian Projects. Invisible is maintained by a different guy, and they both support something like VPN mode or SOX proxy in order to establish Tor connections. There are many pros to using a non-embedded Tor. For example, you can have more than one app use Tor, a single Tor instance, so you don't waste memory on multiple Tor instances on operating systems. There's no need, as for us developers, there's no need to do anything about that because user just configs that entirely outside of our app, and everything just works for the most part, at least. But where can we find the embedded or the different one, the one that we put inside of our app? Well, Orbot on Android very conveniently maintains a list of some apps that use Tor, and if you read a comment here, it will say that this list is here to prevent Tor over Tor. If we go to Tor browser or OnionShare, Briar, or some other apps, we will see that they are using Tor and they have their own binary. They are not using Orbot, they have something that they ship on their own. So the vocabulary is very simple. Embedded Tor is just a normal Tor embedded inside of your app. And also, before we move forward, there are a few different flavors of Tor that you can get. There's Tor, there's RT. RT is the new rewrite of Tor in Rust. It is still experimental, but it's in production in some places. Then we have Orbot, Invisible, Embedded, that can run in VPN and SOX mode. And then you multiply that by Android, iOS, macOS, and Windows, and Linux, and you end up with pretty large amount of configurations to support. That's a lot for developers to test and for testers too. But if what I said before was true, we are all Tor ready. Like, we can just enable the VPN mode, or users can enable the VPN mode, and that lies entirely outside of our app, requires zero setup, and should just work. But there will be some hiccups with that. For example, on-ramps and instance swaps really don't like Tor exit nodes because anyone can access them. We had a talk on permissionless before. That's a permissionless network. Anyone can connect to Tor. Anyone can do anything with that. So off-ramps and instance swaps don't really like that. Also, some normal services that do not block Tor may accidentally block it by web application frameworks or just normal denial of services prevention systems, because exit nodes share IP addresses, and if you don't have a proper Onion endpoint, you may end up with a situation when your server just denies requests coming from the Tor network. But everything else should work. So why should you, as a developer, bother with supporting Tor? Well, there are a lot of things that come with Tor. For example, you get explicit testing for Tor connectivity. You can host Onion services that help circumvent censorship. You can properly handle errors from third parties, and I don't mean like an actual error. I mean when Cloudflare is going down and you are seeing HTML instead of JSON. You get to test that, because with Tor, many things will break that send requests outside just by the nature of the network. We can also make man-in-the-middle attacks more difficult, especially if the network stayed inside of the Onion network. There's less metadata linked to the users because we don't see any IP addresses, and every request looks exactly the same on our backend. But why bother embedding? We can get all of those benefits by just using Tor in a VPN mode. Why should anyone put it inside of our app? So there are some downsides to the external Tor of projects such as Orbot or Invisible. It adds extra CPU load, which on desktop platforms wouldn't be that bad, but on mobile devices it may prevent a device from entering a deep sleep state, which will drain battery because the device will have to be awake even with screen turned off, and you cannot use it with other VPN services. So if you use Mulvad or Tilescale, you cannot use that with a system-wide Tor VPN. So how do we design the embedded Tor inside of our app? Let's take a look at Orbot. Orbot has a lot of features. It allows you to set up how you connect, what port you use, what connection, everything. It has so many options. And we took a good look at this at Cake, and we decided to put an on and off switch that turns Tor on and off. And that's all we support for now. We think that it is enough for most users. In future, we do plan to maybe do feature parity with Orbot, but more likely we end up with a way to edit TorRC file for the power users. But like, okay, I see what we are doing here, but what are we actually trying to solve now? The most requested features that were coming to us is people were trying to host their own nodes, and they didn't have public IP address, or IPv6 wasn't really working on the mobile data. So the easiest way to do that currently is to just expose the node via Onion service, because it's just one command and 2 lines of config files, and we are ready. And also, some people like to say that you don't trust, you verify, but we would like to take that a step further and don't trust if you don't have to. So if you don't want to trust a third party with metadata, then don't do that. For example, if you are sending requests to many services, such as like some even entirely custom, such as services for the NFT pictures, which can be hosted anywhere on the internet, you really don't want them to know that you own that NFT, and that's a metadata that you are leaking if you are not using things like Tor. We also don't want to break any existing functionality, so we wouldn't like to break, for example, background sync that we have in Cake, which if you enable it, it will check on your device if there are any new transactions coming to your address and send you notifications if they do. And we also wouldn't like to increase the difficulty of the app itself. So let's do some coding. First, we will be using RT initially. It's the Rust version of Tor. It's experimental, but it had a Flutter package already made by the foundation devices, which are also in the crypto space. And we decided to go with it because it supports all platforms. It was really good. It worked out of the box, was awesome. It was multi-platform. It really saved us a lot of time. But it didn't work. That's the kind of issue that we hit. It was good when it was working, but when it was not working, we had really non-reproducible issues only. We couldn't connect to some nodes or to like some protocols. For example, Electrum wasn't working at all in Cake, while we could establish connections to JSON RPC of some of the Ethereum nodes, but it was random. One day it worked, one day it didn't. Which I guess was caused by the fact that it's RT and not the Tor used by Tor browser, the old implementation. Overall, it was good. There were no pre-builds in it. It was very easy to implement, but never got merged because it never passed the testing. Then we went ahead and tried the Tor Android, which is maintained by Guardian project. It ships a reproducible binary or a library, we'll see in a second, that you can use in your app very easily. They actually host their Maven repo on GitHub, so it's very easy to audit everything. You can just go there, download the file, and actually, let's do that. Let's take a look at this. If you download it and unpack the file, you can see that there is a binary, libtor.so. And yeah, lib.so should mean that it is a shared object. It's not really a shared object, at least not as far as I am concerned, because it has an interpreter, which means that you can just launch it as a command. It is not a Tor library, it is just a normal Tor that you can install on Debian or any other operating system. Let's quickly verify that claim. If I try to push that file to somewhere on my Android device and execute it as a program, we can see something that anyone who used Tor should be familiar with, the standard notice that happens when you run the Tor for the first time. So yeah, it is a normal binary. So to use it, we should be able to just /libtor.so --torrc path to torrc, and it should be good, right? Right? Well, yes, but what happened to the iOS, Linux, macOS, and all the other operating systems? Well, nothing, but it was working. On Android, it was working, and was working very well. It made it to production with Android only, sadly, but it was very good. So since this path was working, it was known good, then we decided to do it again. This time for iOS. It shouldn't be that bad, right? So there's an Orbot Apple project, which is doing exactly the same thing as Orbot Android, but for Apple devices. And it conveniently lists Tor.framework in direct dependencies in the README, which we decided to use. I personally created a new project in Flutter. I made sure that it abstracts Tor Android from previous steps and Tor.framework in a way in which we can use it in a platform-independent API, because we are in Flutter, we support all operating system in one code base. So I abstracted it. I made a test request to check.torproject.org. It was working, and then I had some other Jira tickets going on. I couldn't work on Tor, so a couple of weeks passed by, and then I'm coming back to the project just to see that it's not there. Like the code that I changed, the code that I depended on just got removed. As you can see in the commit message there's a very sad thing that really made me very angry and very mad. Switch to pre-built XE framework. Because previously it was building Tor. But okay, like Tor Android is also a pre-build, it's a reproducible pre-build, so I'm pretty sure it's just the same thing happening here. No, it's not reproducible, it's a random binary downloaded from GitHub releases, it's not pinned by Git hash, it's pinned by Git tags. I'm not going to rant here about that too much, but it wasn't a good fit for us. Essentially, the maintainer told me to don't verify but trust them, which is not happening. We are touching user funds. We cannot put a binary that someone else compiled in our process namespace, because then they could just steal the coins. We are not doing that. So that's clearly not the path. Let's rethink everything. Let's see what we need to do. So we need a Tor, like any kind of Tor, preferably the one from Tor browser. We need a cross-platform build system, because we are a cross-platform app. And we need, for starters, Android and iOS will do. Then we would like to do Linux, macOS, Windows, all the other operating systems. We don't need a platform-dependent projects. We just saw with that, like it's breaking there. If you depend on 5 different projects in your cross-platform app, then you have 5 different issues to solve whenever something changes. So we don't want that. We want a really simple solution. Ideally, reuse something that we have, like one place to manage builds. We want them to be reproducible and ideally bootstrappable as well. And we went with a system that we already have, which some Bitcoin OGs may know. It's a contrib/depends directory in the Bitcoin core. It's deprecated, it's not there for many years now, but it's still used by Moneros, and we support Monero, so we still have it around. It's very simple. It's the perfect build system. I love it. You just make, host, and it just builds. The package definitions are very easy. Then you make a list of the packages. And actually, I lied. We have a rewrite of that in Go, because do you see this? Like this is terrible. This is a macro that defines that. We cannot debug that. I don't have skills for that. But we have a rewrite of that happening in Go, which just uses JSON, which is slightly easier to maintain and slightly easier to read than nested macros in makefiles. And okay, so then we need to build lib event, OpenSSL, exe, Tor, and magic secret ingredients that we will get into later. And then we need to do that for Android, iOS, macOS, Linux, Windows. And then we also need like 40 build dependencies because we want to bootstrap the build from source, which is very difficult. But we did that. I will skip how that happened because it was really painful and very long time. We had a fat XE framework for iOS, macOS, and all the different architectures. We have .so for Android, and we have an easy way to expand the support to Linux and Windows in future. That's coming very soon, and all of that is reproducible. But do you remember this slide? I showed you that the Tor libtor.so was a binary and not a library. So how are we getting the library, like an actual one? We are actually building a static archive of libtor. I found out by reading a makefile in the Tor project. It was quite easy. And then instead of reading documentation, I just created 100 lines of C++ wrapper that exposed the static archive in a shared library that we can just load. There are a couple, before I go there. So essentially, instead of running a command, we just load the binary with the param. So it's pretty much the same API, just slightly different way to call it. Also, Tor API.a we could use the Tor API.a directly, but there are some quirks to that I don't really like iOS simulator and iOS conflicts when doing that if you don't do that fully properly, and the code remains unloaded unless user starts embedded Tor, which is really important for us, because if users don't want to use Tor, they shouldn't have any Tor code in memory. And also, do you remember this switch on and off? We actually removed half of the functionality with this update because it doesn't turn off. You can't turn Tor off. I mean, you can turn it off. You can start it again if you are using it as a library. So we just don't do that. We gracefully stop using Tor, so it's still running in the background. If there are some connections made to it, it can finish at whatever speed they want. And but yeah, we won't be using it for any new requests. So that's it. We have a working Tor, right? There's nothing else. Where's the VPN? Like I told earlier about the VPN that routes all the traffic. Like where's the VPN here? Well, the fun is just begins. Currently, nothing changed in our app. We just shipped a binary, library actually, that we run, and that's it. Like it just uses some memory and some storage, and it doesn't do anything. So, how to properly route the traffic through Tor if you have if you have it embedded in the app? Well, you have to start a SOX proxy, and then you have to route all the requests through it. So the best way to do it is plan early, make all connections originate from a single class, have it really well prepared. But sadly, Cake Wallet is 7 years old, and I joined it 2 years ago, and Tor was implemented a year ago. So this option is clearly a no-go for us. So instead, we had a PR, a big one, I would say, that changed every single place that we make a HTTP request into a proxy wrapper that then sees if we can use Tor or no and routes the connection through Tor or it doesn't. It is just a simple wrapper about standard HTTP methods, some of the Dart IO clients that are also used by some libraries, and it also supports a really cool thing where you can pass it an ClearNet URI and Onion URI. So if Tor is enabled, it would prefer the Onion endpoint, but if it's disabled, it will go to the ClearNet one without any logic in the in other places of the app. It just happens on the request level. Then we have third-party libraries. But how do we tell them to respect our proxy? Like they have no idea that we run Tor. Well, chase and hunt them. Like open midden proxy, put it between the internet and your app, make it stuck there, use your app, and look for requests. If something looks like a Tor traffic, don't touch it. If something looks like a web request, go see where it's happening, manually try to patch it, and to respect your SOX proxy, and repeat and repeat and repeat. We are still in progress of doing that because there are so many things that over 7 years have been added to the app. So it's a really long process. But yeah, that's pretty much the only way to go if you didn't plan that 7 years ago. And that's it. By now we have a much better understanding of the app networking. We have a single place, in theory, that connects to the internet. We have an easy way to add new networks or proxies. For example, if you feel like supporting I2P, it's a matter of starting the daemon, configuring the SOX proxy, and that's it. We can also enhance the app in future with per domain or per IP routing scheme. So if user wants to route some traffic through Tor, they can do that, and the rest can go over ClearNet. And yeah, also as quick bonus, when I was flying here Cloudflare did a little oopsie and was offline. And we use Cloudflare in Cake Wallet for a first-party API that shows prices of cryptocurrencies. The support was flooded by it not working. And yeah, support just told users to enable Tor because we had it hosted on Onion endpoint, which doesn't go through Cloudflare. So when people enabled built-in Tor, it was just working because it wasn't affected by it. So it was pretty cool. So a quick TLDR of the talk. Use established solutions. Don't go with RT or the fancy new Rust rewrite. If there is a Tor binary that powers Tor browser, tails, and everything, it's probably good for your project that's probably smaller than Tor itself. So do not use experimental software unless it's production ready. And for cross-platform projects, unify as much code as possible. When we were going with Tor Android and Orbot Apple, it was just a lot of extra code trying to make it work with the same API in Dart. It's a lot of work. I do not recommend that. That feels like a waste of time now, seeing how simple the API is with around 100 lines of C++ code, and that's it. Keep things simple. Like C API is much better than whatever else is the native thing at this very moment. So technically we could use the native APIs, but going with the simple solution is just easier. And follow standards and conventions. For example, there's SOX server environment variable on Linux that isn't a standard, but is pretty much a convention. And it made respecting it in our proxy wrapper made Tails OS support much better, because everything was properly routing through Tor on Tails. And yeah, thank you for attending. If you have any questions about Tor, feel free to catch me here or email me, add me on Twitter, or check the Tor implementations that we have in Cake Wallet at the GitHub URI. So, thank you.